Alright, you've had a little bit of time to work on these. Now let's go over them together. Remember what we said a while ago, that this, I'm fixing to get the wrong thing going, this is the atomic number. This is the mass number. So the atomic number we already know is 35. The mass number is 80. Because we know that the atomic number equals protons equal electrons, I can immediately fill in protons as 35. I can immediately plug in electrons as 35, and then I'm going to use mass number minus protons equal neutrons. So my mass number is going to be 80 minus 35, which gives me what? 45. 45. So I have 45 neutrons. So everybody should have worked that problem, and I hope you all have it correct. So the next one I ask you to do, oh, there's no symbol, so I have to read the text. If an element has an atomic number, so what do I know? I know that the atomic number, back up. I'll do that usual thing I do when I'm there. Alright, so I know that the atomic number is 34. So the atomic number is 34. So if I know the atomic number is 34, I also know the number of protons is 34. And I know the number of electrons is 34. And I know then that I've got a mass number. Maybe that'll help. I know mass number equals protons plus neutrons. This time I'm going to have to do the same thing I've been doing. I'm going to have to subtract, but okay, I see I've got a 78, so I've got mass number minus protons equals neutrons. 78 minus 34 is going to equal 44. So my number of neutrons is 44. Now I threw you a real ringer right here. I'm going to pause for just a second because I got to get my book out because I don't remember which one element to see. Alright, now we don't know what element it is. We don't have one of those fancy symbols over there that tells us what the element is. But a while ago I told you that the elements on the periodic table were numbered sequentially. So look at your periodic table, either the one I gave you the other day or look at the one in the back of your book. Find number 34. Everybody find number 34 because that's the atomic number. And when I find number 34, I find that that element is Se. So my complete symbol is going to be, got to get the pen again. The complete symbol is going to be Se, and what do I have to put up here? The mass number, 78, and what do I put down here? The atomic number, 34. So that would be, if you're asked to do the complete symbol, this is what we're talking about, what it's talking about right here, where you use your periodic table, find the correct symbol, write the mass number at the top and the atomic number at the bottom. Alright, so let's erase all of this and go on to the next slide. Hope all of you got that one right. Alright. Okay. Now, this one has got a little shade of difference to it again. Again, I'm going to write them down one more time if I can find my little marker on this thing. Where are we? There it is. Alright. I'm going to write them down again. Atomic number equals protons equals electrons, and the mass number equals protons plus neutrons, and the symbol has the mass number up here and the atomic number here. So in this case, I have 91 protons. 91 protons. There it is. What's the atomic number? Well, must be 91 because they're equal. The number of electrons, 91, because they're equal. Mass number. Doesn't tell me the mass number. How am I going to find the mass number? I'm going to use this formula. The mass number equal protons plus neutrons. The protons we said was 91 plus the neutrons, which, oops, didn't mean to write neutrons, I meant to write the number. The number of neutrons is 140, so I add those together and I get 1. Don't worry about significant figures, these are counted things, so they're all exact. Protons are whole things, you don't ever have a half a proton or half a neutron or half an electron. So these are whole things, they're counted. Don't worry about significant figures when you're doing this type of problem. So I'm going to say 4 nines, 3, carry your 1, so 231. 231. The complete symbol. Well, how do I find the symbol? I'm going to go back to my periodic table, and I'm going to look and find number 91. And number 91 is PA. And up here, I'm going to write the 231, and down here, I'm going to write the 91. Alright, these ought to be pretty easy, but if you don't learn this, ain't nothing easy. You must learn those two little formulas. They're not that hard to learn. You could have learned them when you were in 3rd grade because you'd worked hard enough then to have learned them. So get after it and let's learn them. Alright, the next thing. More on the symbols. Alright, in this case, I have 78 electrons. What do we know about electrons? Atomic number equal protons equal electrons. So if I have 78 electrons, how many protons do I have? 78. What is the atomic number? Well, if I have 78 of these and they're all equal, I'm going to have 78. And then I have the number of neutrons given, the mass number, remember, mass number equal protons plus neutrons. And so the protons is 78 plus 117, excuse me. It's going to be 5, carry my 1, 195, assuming that I'm doing this mental math correctly. So the mass number is 195. Again, go to your periodic table, look up number 78. Number 78 is PT, and we have a mass number of 195 and an atomic number of 78. So this would be the complete symbol. Okay? Alright. This is another way of naming isotopes. Isotopes, we can put the mass number after the name of the element. So we take the name of the element and what would this be? What would this number 12 represent? The mass number. How could I find out how many protons that carbon has? Look on the periodic table. Find carbon. And when you find carbon, you'll find that its atomic number is equal to 6. So it has 6 protons and 6 neutrons. Remember, mass number. Mass number. This number can change. This number can never change. If it's carbon, it must have an atomic number of 6. It must have 6 neutrons. has to have 6 protons. So the mass number can change, the number of protons can never change as long as it's carbon. The number of neutrons can change. And when the number of neutrons changes, it's called an isotope. All right.